Yeah, thank you, Dr. Chari, for inviting me to deliver the guest lecture on innovative applications of 3D printing. I hope my screen is now visible.
Yes, sir. Yes, sir. Your screen is visible, sir.
Yeah. So before I start today's session, I am calling innovative application of 3D printing. So why 3D printing is so innovative? Earlier, you don't have this word coming with other like CNC machining or other manufacturing process. Let us see this video and understand how innovative this is. Only your idea stops. No, is my the screen is visible? Sorry.
Yes, sir. Your screen is visible, sir.
So today is Vinayak Chavithi, big festival for most of Indians, and I want to start with Happy Ganesha. Let us see how you can print a Ganesha with 3D printing process. Right. So my idea here is there is no stopping for 3D printing. Wherever you want to have this video is visible, no? There is no stopping of innovativeness in 3D printing. So you can use anywhere. Only your imagination, your thinking to change. You can use 3D printing for such wonderful applications. So like scanning the existing object, making again reproducing the same thing. Like for example, we have very old architectures. So you expect to lose some time after some years time period. So you can preserve the digital format of all those architecture. Like for example, I am from Warangal. I don't have glimpses of 1,000-pillar temple. We don't know what happens after 1,000 years. So you can scan the entire 1,000-pillar temple, store in a digital format, and print using a 3D printer, and you can produce as the original. You can see how easily you are able to print a Ganesha by just scanning the existing one. This is where the 3D printing is all about. Just to show why it is becoming so popular. Any field can use this technology. You may be an art person. You are a social scientist, or you are a technical person. Anyone you can produce how beautiful the 3D printed Ganesha is. Just to show you how complex things you can print easily using I think in future we will be getting 3D printed Ganesha outside also, professionally also. I think the video was visible, right, Chari?
Visible. The audio also very clear. Yes.
Right. So just to make you understand the innovativeness of 3D printing, only the idea is you should have the idea. So whichever field you want, you can use it. So what you are seeing on my screen is left side, you are seeing the top left side corner. Most of you might have witnessed the launch of Perseverance rover by US in the month of February to Mars, our next planet of living. So right in future, we are expected to our next generations. I think another 6 to 7 generation, we'll be seeing people traveling to Mars also, like now you are traveling to US. I think in another 1.5 to 2 years, we will be traveling to Moon as per the Elon Musk target of now sending people for tourism to Moon. So next step will be developing colonies in Mars. I hope you have seen the concept model of Elon Musk of Mars colonies, how to build all those things. Their 3D printers will be used a lot. So the application of 3D printing in space is now very popular. It's becoming very, very interesting. And next, right side, you are seeing on the right side top corner, a car and automobile. You see the OVRMs, overview rear mirrors. Anytime have you expected you put a LED light in these OVRMs. It's very difficult to put such a complex part inside OVRM in the existing one. But using 3D printing, it is becoming a reality. So 3D printing in automobile sector is another area where a lot of applications are coming up and already started using. Most of us now to watch movies, especially we Indians like 3 things. One is cricket, other one is good food and movies. Entertainment is movies. So right. So in most of the movies nowadays, 3D printing is used a lot. It's now like Hollywood movies like Iron Man, or the Superman, or the Jurassic Park, or the or you Avatar movie, or you might have seen big movies like Lord of Rings, the Battlefield in Lord of Rings, and all those movies, they started using 3D print technology. So application of 3D printing in entertainment is another popular area of application. And next, you are seeing on right side a shoe, particular type of shoes, where you are having this, you are able to see a outer sole fixed with some kind of, no, a particular kind of item, right? This is at the bottom, you are having a gel-like substance at the bottom to the sole. So it will help the athletic to run faster. So this is called Reebok liquid shoes developed by Reebok company. And not only Reebok, but all big companies like Adidas, Nike, they are all started using this technology. So application of 3D printing in sports industry is becoming a big area where you can do a lot of work in that. And here I am showing you a very big application of 3D printing coming up in few years in agriculture field. Because we Indians, still we say our Indian economy is backbone of Indian economy is agriculture. So agriculture, we should now start thinking about how to use this technology for agriculture, helping the farmers, the villagers, because what are the technology inventment should go to the grassroots level, help people to have a better living. So in this case, you are seeing a very big fluffing tool, right? For example, in this fluffing tool, some spare parts fails. So this entire big thing cannot run because there is a failure in the small part. So for getting the small part, again, you have to wait from a OEM or original equipment manufacturer to send the part. And if, for example, there's a pandemic-like situation, then your supply chain is not working, then how to replace that part, and so that your productivity will not affect. So if you have a nearby 3D printer, as just now I shown the scanner, using a scanner, you can scan the existing part and then produce the same thing, and you can supply to the farmer. So application of 3D printing in agriculture is a very big area of research. So now we are hearing the term called urban farming. So because it's not that farming requires very big fields and you require land and all those things. Now people are started to make their regular eatable vegetables and all those things. They are now getting in done in their rooftops or in their home itself. They're able to make. So that is the application of 3D printing is working a lot in this area. I'm going to show you very interesting clipping how 3D printing can be used in urban farming. Not only that, you see at the bottom left-hand corner, now this is the future where you will be printing the homes itself directly. I hope in China already they started using 3D printing for civil construction industry. So you can start using very big 3D printers for building homes within less time. This is a recent 3D printed home printed in Chennai L&T in Tamil Nadu. So they're taken to produce this one in less than, I think, 100 hour or 160 hours like that. Within less time, they're able to produce this home, a 2-bedroom home they are able to produce. So in civil construction, in the case of creating housing for so many people, those are houseless and those who are not having their own home. So you can use 3D printing. Government in its next projects where they want to build homes for homeless people in large numbers. So they can plan to use 3D printing. They can produce things faster, quicker, and with good accuracy and with good quality. That's how you can use 3D printing for civil industry, right? Not only that, you are able to see the application of 3D printing in food industry is also coming up a lot. So making your own type of customized pizzas, customized snacks, or customized pastries, all these things, you can use a 3D printer, especially for food application. Companies like Harsley and very big companies, they started already using it for making the chocolates, pizzas, etc. In fact, NASA in its next expedition to Mars, where they want to send human beings to Mars, and presently they have sent rovers, but in future they want to send astronauts, 2 astronauts to Mars through a rover. So for those people, when they stay on Mars, they require food to live, right? So that food you can produce using 3D printing technology. In fact, I am going to show that video, interesting video, where NASA is now is already given a contract to a company in US to produce a printer which will print the food for the astronauts in the space, in the Mars. So application of 3D printing in food industry is becoming very popular. Now you can see a particular type of jewelry. I hope you please observe my cursor. So this jewelry is very complex in shape. So earlier, imagining of making this type of jewelry by conventional method is very difficult and also very time consuming. But with the help of 3D printing, you can create such wonderful jewelry within no time. And like you can use co-investment casting, that is indirect way of printing jewelry, or you can go for direct jewelry printing. So application of 3D printing in jewelry is becoming very popular. The other application is you are going to see 3D printing in what you call antennas in electronic communication. Horn antenna. This is what you are seeing on screen. We have printed a horn antenna. In fact, one of my MTech students is working on this project, and we are able to produce a horn antenna. And this horn antenna can be used for communication purpose. Earlier, they are making using the conventional sheet metal work, but with the help of a 3D printer, you can produce a very accurate antenna of what are the shape you require, and that can be used for communication. So application of 3D printing electronic industry is becoming very popular. Not only that, the bottom right-hand corner, you are seeing a horse coming out from a wall. It is like 3D effect. It's not like simply putting a plain paper, sticking a plain paper on the wall and seeing that it's a 2D effect only. But now if you put this type of props on the wall, then you see as if the wall is coming, the horse is coming out of the wall. So this is a 3D effect. So because we all know when you constructed your home, desired home, independent home or flat, etc., you want to have something, not seeing a bare walls. You want to see some kind of a different effect because people are now spending some money or some time in making their home look beautiful, right? So that's where 3D printing can also help in interior decoration process. So in fact, most of the people are now using 3D printers, FDM, especially FDM 3D printer for this interior application. So, right. So I hope by this time you might have understood what is going to be in my lecture. So in my lecture, I am going to concentrate in these areas, how 3D printing can be used in aerospace, agriculture, sports, entertainment industry, food processing industry, jewelry industry, automobile industry, electronic industry, construction, interior decoration. Today, I am going to show a gamut of areas where you can work, and it depends, you may be a person from arts, you may be a person from, you are an architect student, or you are some kind of what you call a food processing industry person. So you can now start thinking innovative because now the world demands innovation, something different, something new should come out. So these are the various areas. These are only, I'm showing some 10 areas, but there is no boundaries for 3D printing. You can use additive manufacturing 3D printing in any area where you have some idea, where you have some intention to do some innovation, you can use 3D printing. It is only your way of thinking should change. So you can use 3D printing everywhere. Let us see first with aerospace applications, right? So what I am showing on your screen is the bottom left-hand corner. You are seeing the rover. Just now I informed that NASA is going to send two astronauts to Mars in future. So for that, they have to send a special purpose SUV. It's like SUV vehicle. They are calling rover, but it's like a small type of SUV vehicle where this will be lifted from Earth to Mars through a huge rocket. And now when you want to shift such a huge one from Earth to Mars, it's not that easy. So in this rover, around 70 parts are made with 3D printing technology so that the weight comes down and without affecting its strength and performance. That will be withstanding the harsh climates of Mars, etc. This is where NASA is already using this technology. I'm going to show this desert rats rover, which you are going to see in short while in the video, how they are using this technology. In the right side, you are seeing the Perseverance rover, which was recently launched in February. And you see in that 11 parts are made with 3D print technology. So here top, our own Tejas fighter, lightweight, multi-role jet fighter. This is developed in using 3D print technology a lot. So I'm going to show you how Dr. U.V. Chandrasekharan sir, who was the former director of GTRI, they use this technology in making several parts in this Tejas so that the cost comes down in making those things. In the top left-hand corner is what we have made in our college, in our work. This is where we made a CubeSat satellite, entirely 3D printed, a nano satellite, which is 3D printed, and you can use 3D printing for making such type of nano satellites. So nano satellites are satellites which are sent for some special applications. Let us move ahead. So this is what I said, 3D printer, 3D printing a space vehicle. This rover, which has a pressurized cabin to support astronauts, includes about 70 FDM parts. These FDM parts include some kind of fixtures like this. You can also see some housings, AC ducts, etc. This is a desert rats research and technology studies, and the rover about the size of a Hummer and boasting a pressurized cabin to support humans in space. So it is being already developed by NASA and tested in Arizona deserts. Let us see this video and understand how NASA is using this 3D print technology for making this rover. Are you able to see the video? Sorry?
Yes, sir.
Audio also you are able to hear?
No, please start, sir. Just we will see.
Just I will show. Now please tell me. Are you able to hear the audio?
Also clear, sir. Audio clear, video clear, sir. Both
of excellent service to our nation. And its time had come. It had been a fantastic program. It had done amazing things. But now NASA is ready to really take the next step, which is a more continued presence in outer space beyond low Earth orbit. Our ultimate goal is to get humans to Mars. When we started this project, we thought we were really clever thinkers. We had some technology we wanted to explore that involved multiple wheels and the ability to turn in any direction. They thought, well, what if we build a cabin and have the crew go out for multiple days? And that's really where this small pressurized rover concept has really evolved into the space exploration vehicle.
So the SUV will hold 2 astronauts. They basically live in this module, in this rover. It's your own personal SUV in space. You always want it to be as light as possible. You also want it to be strong enough that it's got your safety factors, that nobody's going to get hurt. You're going at several thousand miles per hour just to escape the Earth's atmosphere. So you've got to be able to handle all these vibrations and all these different things just to be able to get out into space. And the vehicle can't be damaged. There's probably around 60 to 80 parts on this particular rover. It's all done by additive manufacturing for a lot of different reasons. You know, sometimes traditional manufacturing methods don't really work for some parts that you want to build, where you can do it with additive manufacturing, and it's really simple. It really takes no effort for what would otherwise be a very complex process. Whether it be ducting that's got flame retardant characteristics and properties to it to help keep people safe, or different fixtures and different parts. There's absolutely a place for additive manufacturing. There's a lot of things that you don't see that really get to go on is the design verification and the functionality checks of parts before we send them to be manufactured. If the final product is not going to be an additive manufacturing plastic part, we will do it in a rapid prototype fashion where you'll get it back in maybe an hour, a day. What that allows us to do is be able to check our design and make sure that everything's going to work the way we think it is. Sometimes vendor components are a little bit different than what you anticipated, what the drawings say. So you're able to functionally build up this assembly and check it to say, hey, this is what we want, or hey, we need to make some tweaks. So by doing additive manufacturing, rapid prototyping, it allows you to keep your costs down. Everybody's got a budget to deal with, and we're no different. Being able to make a difference and leave my mark is really what inspires me. You know, that's what gives me the drive to do what I do.
Yeah, I hope you have watched this video. This is developed by Stratasys company. And not only that, you can see our own aircraft. 1 minute. Yeah. So this is our Tejas aircraft by India, lightweight multi-role jet fighter. You can see in this, the cover engine prototype has 2,500 parts produced by FDM additive manufacturing process. The model helped engineers best lay out complex piping runs. According to the observation made by Dr. U. Chandrasekhar, former director of GTRE, with FDM, they created an engineering prototype that perfectly reflected our design and intent and facilitated the complex engine development. So, so this is what they found after using 3D printing. They found that the conventional fabrication is costing around $60,000 and it will take 12 months. Whereas direct digital manufacturing using FDM technology, they are able to produce within $20,000 and within 1.5 months. That means the saving in terms of money is 66%. In terms of time is 87.5%. That's how 3D printing is helping people in such type of applications. The next application, what I'm showing is why the screen is not going up. So this is a NASA Perseverance rover, which was sent in February 2021, which carries 11 metal parts. So this is and earlier they have sent Curiosity rover, which also used some 3D printed parts. So in the NASA, in the Perseverance rover, they use this instrument called Planetary Instrument for X-ray lithochemistry pixel. It's like a lunch box. This is what you are seeing on the screen. It's a device which will help the rover seek out signs of fossil microbial life by shooting X-ray beams at rock surfaces to analyze them. So this outer shell of the pixel, one of the instrument aboard NASA Perseverance Mars, includes several parts that are made with 3D printed titanium. So you can see there are several parts which are made with 3D printed titanium, like this part you can see here. Similarly, in the same Perseverance row, they developed another instrument called MOXIE instrument, which is basically called Mars Oxygen In Situ Resource Utilization Experiment. That means when the astronauts want to come back to Earth, so they require a propellant for which oxygen is required. So those oxygen you want to produce there, so they developed this instrument. So in that instrument, they use this. Why? This is somewhat disturbing. So this heat exchanger they made in that experiment, they made using the 3D printing technology, heat exchange. And this even the Curiosity rover for Mars expedition, they sent earlier. So the prototype for making the prototype, they made 3D print. They use 3D print technology. All the parts are made with FDM 3D printer. So they tested it and they found it is successful. They like that they made wheel assembly, robotic arm assembly, suspension assembly, and cam and rover assembly. All these things they produced initially before sending it to Mars. They produced using 3D print technology. Like Ultimaker, they use and produce all these parts. So what I'm showing is we have done a project with my student. We have done MTech student. We have done a project on nanosatellite optimization of nanosatellite structure and prototype manufacturing using FDM RP technology. So this we got. I got the chance to present in ISRO in the National Conference on Large Scale Multidisciplinary Systems of Nation Significance held in 2016. So this what is our idea is, and it's a basically a nanosatellite. Why it's called CubeSat is in the form of cube, right? So it is a nanosatellite which is ranging from 1 to 10 kilograms, and it is called basic nanosatellite is 1U, and it has a volume of 1 liter, that is 100 mm cube. So maximum mass of 1U is 1.33 kg. So it's like a modular. You can add another U, it becomes 2U, 3U, like this you can increase. So you might have seen ISRO launches some 40 satellites at a time, 50 satellites. In that, most of the satellites are nanosatellites. They do some specific purpose like excavating the minerals or identifying for defense application, identifying the enemy hideouts, or you can use it for getting like a weather forecast. There are some specific targeted application you can use such type of satellites. So we have taken the design of this satellite from California Polytechnic State University. We have taken this design and is also approved by NASA earlier. That is for the California University, the NASA they approved this design, and we have taken that from one of the paper. And then we have modeled it. There are different models you can make for that. You can go single piece CubeSat concept or a modular rail design concept or a pumpkin structure, etc. So we went for this type of structure. because it has got less variety of parts and makes the design simple, and it is easy to expand from 1 year to 1.5 years. So this is what we have made using this technology. I think how this has to go down, this pop-up is coming every time. Sorry, how to...
Sir, your skin is perfect, sir. We are not seeing anything.
But for me, what is happening is there is some projection is coming up. It's some screen sharing. The bar is coming. Screen sharing bar is coming. It is stopping my view. For you, it is visible entire screen?
Yes, sir. Now it's good. Now the total screen is visible, sir.
For me, there is some kind of obstruction coming up. So like mute, start video, all these things is coming up. Okay. So I think this bar is obstruct.
Just
Okay, right.
Pull down,
So,
sir. Pull down. Maybe it will become.
Let it go to. Yeah. So this is a model. So we made it in a model it in a, so in the CATIA, so we modeled this one. So you might have seen these are the racks where they put all the printed circuit boards for doing some survey, and they pack the entire thing. So we produce using Ultimaker the entire these CubeSat, and this was assembled. Even the screws, bolts, nuts are also made using 3D print technology. So this all 3D printing can be used in space application. Like you can also use for micro air vehicles or drones. You know, all drones are now being used for different applications, starting from military application to agriculture application to carrying emergency medicines, or from in the hospital sector, or doing your marriage function shooting. So all these things, you know, drone has got so many applications. So people are using it for in a war zone. They are using it in agriculture for spraying the pesticides or so many things. So you can make such complex shapes using 3D print technology. Even the micro air vehicles, which looks like small insects that can be used in using 3D print technology, you can print those things very easily. Let us come to the agriculture sector, where you can think about how you help the farmers. Let us see this kind of big fluffing tool, especially it's a heavy expensive machine it is. To replace just one part, it can be quite expensive, or the part that farmer is searching for it may not be available on the market anymore. So additive manufacturing is an amazing solution which makes it possible to print spare parts for farming machines. So you can make the print the spare parts using reverse engineering, and you can make the tool, the machine to run easily without depending on the OEMs, right? So like that, this is another concept called urban farming. So it is started by a company called Italian startup company called Hexagro Urban Farming. So this company is trying to innovate to urban farming and hanging gardens. So you are going to future, you are going to grow the plants in your home with a hanging garden concept. So here you are seeing a particular type of garden, which is like a hanging garden, and you have connectors here. So these connectors are specially printed using 3D print technology. You can see the complexity of the structure of this connector. So you are having bars here. So you connect bars and put these circular plates on these connectors, and you can start growing the plants inside this. So this is called urban farming. Let us watch this video.
Have you ever wondered
on
how to
urban
feel
farming.
closer to nature in your house? This is the living farming tree.
Just I'll start from beginning.
Have you ever wondered how to feel closer to nature in your house? This is the living farming tree, a uniquely designed plug-and-play system to grow food anytime, anywhere. Insert the bars and the connectors, place the farming modules,
So
and
this is what
transplant
you
your
are seeing.
seedlings.
These are the bars.
Plug the system to
And you can see these are the connectors. These are the connectors. You are putting bars and joining them. So these connectors you can make using 3D print technology. So that you can grow the plants inside.
plug the system to electricity and connect to a Wi-Fi connection. Download the app and you're ready to grow. Through its modular sensors, the living farming tree will measure several parameters in your house and will automatically adapt the system for the efficient growth of your plants. When the system is in need of attendance, it will send push notifications directly to your smartphone. Use your smartphone to plan your crops, monitor your system's activity, and gather information to share with your fellow urban farmer friends. Easy to unpack and assemble, you will be able to adapt the living farming tree to the space available in your house and start producing delicious, healthy food with just a few clicks. The cities of the world host over half of the global population. By 2050, this number is expected to grow up to 80%. Who will farm the food we need to feed our planet? Collaborative urban farming is a regenerative solution to decentralize food production, enhance its supply chain, and increase food quality within cities. But sometimes weather conditions are not ideal, crops are attacked by plagues, and space available for farming and time for maintenance can be limited. The living farming tree is an indoor farming system developed by taking inspiration from nature, mimicking strategies to reduce space while maximizing yield of production. It uses aeroponics, the most advanced technology to grow food without soil. You can either start with a basic configuration and scale up your system to produce more than 200 plants, or you can buy the full configuration from the start.
Hi guys, it's Alessandro. We wanted to invite you all.
So this is a very interesting concept. Even you can use 3D printing for testing agriculture devices. So like this, you have a metal part here. So before you make the original metal one, you want to test its functionality, how it is withstanding the force, etc. So best for test processes, 3D printed parts can actually hold up the physical pressure. As it is really cheaper to test the 3D printed parts, and the process is also quite simple. So you can make a prototype of that part using 3D printing, test it here, your design, after you do topology automation, any other design iteration. And once you produce this part, then you can test if it is functioning well, then you can go for the metal one. So that in that way, you are going to save a lot of money, and also the time you spend on making a metal part, all those iteration you can save. Cost also comes down a lot. So for testing agriculture devices, you can use 3D print technology. Even the 3D printed drone can use for tools to carry out computer control tasks such as mechanical weeding and watering service or doing pesticides, etc. You can use this drone in your agriculture field. Not only that, now you want to pick some fruits from a very tall tree. So where climbing the tree is getting very difficult and plucking those things. Instead of that, you can use a 3D printed triclaw fruit picker, which can be used. Tool can be used to reduce labor and efforts of climbing high trees. So you can pluck those fruits from there, and you can use it there. Not only that, you can also do sprinklers. You can also make different variety of sprinklers with more watering capacity like this above, and it can be used for crops like paddy, potato, and soybeans, etc. So printing such different types of sprinklers, especially for gardening or agriculture purpose, you can use 3D printing a lot. So that's what I want to tell you is, please start thinking in some innovative ideas. So you are in your domain field, you are doing some mechanical engineering, but your mechanical engineering knowledge with the 3D printing skill set, you can help so many people. You can work with a farmer, you can work with a doctor, you can work with a you can work with a sports person, you can work with a film industry person, wherever you are interested. So 3D printing is such a wonderful, such a innovative technology that satisfies for example, most of us do some job which we don't much like, but you are interested in doing, for example, working in a film industry. With this skill set, people are ready to spend so much of money in films. Now you see the budget of films are, I think you might have heard this Hollywood movie, the budget of the Hollywood movie is high, very far higher than our Indian Mangalyaan mission, Mars mission, right? So that is the amount of money you are spending in filmmaking. So if anyone interested in filmmaking with this skill set, with this skill knowledge, you can help the producer, you can help the directors making such a very big movies, wonderful movies, and you can be a part of the technology, right? So like this, you are coming from a remote village, you can help your farmers, you can talk with them, what is their problems, etc., and get from there the problem statement. And you can use this skill set in helping them, making the things faster, quicker, and with a more better quality. You can help them and make those things very easier, right? So that's how 3D printing can help you in doing several applications. So like, let us see the sports industry. It's another area where 3D printing is being used a lot. So in fact, you are seeing what you are seeing on the screen. The right side top corner, you might know already seeing this stumps, right? So the stump and bales and all this is called a wicket system, is called zinc wicket system, where you are putting LED lights inside the stump. So these LED lights will help the people, will help the umpire to make a correct decision making process. So 3D printing in cricket is gentleman's game, is another very big application they found. And you can also see the special kind of shoes used by athletics for running faster, or even the golf bats, or the riddle, what you call this is a helmet, protective helmet used in baseball in America. And not only that, in even your cricket, the batsman or the person can wear this one or a safety gear. So you can use 3D printing for safety gear in sports, right? So the application of this purpose is LED lights is to make a correct decision, and also which will make the spectators gets, surprised to see a light glowing from a bail or from a wicket, etc. Can you imagine how to put such a complex electronic circuit in the bails or stumps? It is not that easy. So you can use 3D print technology for this. So in fact, this is developed by an Australian mechanical engineer called Bront Eckermann for a company called Zing International. And they use 3D print technology for printing this stuff. This is called zinc wicket system. Not only this, Reebok, as I said, the shoes is designed for distance running, cardio workouts and comforts. So this is they are having a what you call using the proprietary layering. They created an entirely unique and high performance athletic footwear faster and more proficiently than ever before. And is more interesting about this manufacturing process. They are not going to use the traditional molds. They are without using traditional molds. They developed their own technology called liquid drawing process, that is pneumatic metal extrusion via robotic arm. These are different 3D printed they develop. And what it will do is it will help when running a certain amount of energy is going to the ground. So when the shoe hits the ground, in this case, it absorbs the energy and then it returns it. That's why it's called high rebound shoes. It is called. So this is called Reebok liquid shoes, and it is very popular technology used in most of the applications. Not on Reebok, but you can also see companies like Adidas or Nike or Under Armour or New Balance. All these people started using this 3D print technology. Like, for example, Adidas uses direct light sintering system, carbon material they use, they polyurethane, and they make midsoles, upper arms, and other parts like cleats, heels, and outsoles. Or Nike uses SLS technology, selective laser sintering technology, and using a thermoplastic polyurethane powder, they produce midsoles and other applications like upper arms, uppers, etc. Similarly, SLA from this Under Armour, New Balance, these are other companies. So what you're seeing on the screen, this technology is being used by all these big branded companies of shoe manufacturers or the sports gear manufacturers. They adopted this technology very quicker, and now they're doing wonders. That's why even the cost of these type of shoes from these branded companies are somewhat costlier than the conventional, but still they have their own life. They have their own quality. You cannot compare with the Reebok shoes with another local shoes, because the quality and the comfort, everything that you get from the shoes is entirely different. Especially when you're a sports person, people start use such type of branded company sports kit. Let us see this. Watch this movie video. And how 3D printing can be used in sports. sports. Not only that, even in entertainment industry, people started using this technology. Like these movies like Jurassic Park, Pacific Rim, Man of Steel, Watchmen, Spider-Man, a lot of rings, all a lot of rings, such a big, huge battle. You can see that battlefield, it appears like very realistic one. I don't know how many of you seen that movie. So, but they created using 3D printing technology, they created such kind of scenarios. I'm going to show you that video where such big battlefields are created. And you can see the avatar in that mask of that, where the actors wear the mask with some special effects. They are made using 3D print technology. Or the Kryptonic city of Superman, that the Kryptonic city is also produced using 3D print technology. Or Jurassic Park movie also, they use this technology a lot. So in Hollywood earlier, they used to depend completely on computer graphics, but now because of 3D print technology, they are able to produce actual physical models, and they're combining it with graphics and making it more realistic. Like the movie called Pacific Rim, where you see huge gigantic robots, or the real steel, or you might have seen a movie called Transformers, where you see huge robots fighting and all those things. So they use a combination of CG computer graphics plus the realistic 3D model so that it appears more realistic. Earlier, they used to use only graphics, CGs, right? So let us watch this movie. There is a studio called Legacy Studio in Hollywood, which uses 3D printing and technology a lot, like FDM technology or PolyJet, Object Pro, PolyJet, everything. They created so many wonders. In fact, if you see that Legacy Studio, it is run by engineers. It appears like like industry only, not like a film making one. But you see a lot of mechanical engineers, electronic engineers, computers engineers, or all these architects and all these casting people and all these people work together making such big, no, surprisingly very big parts, or the props, or the what you call a mask, or anything like you call figurines. All these things they make using this 3D print technology. Let us watch this movie.
Legacy Effects creates practical effects for hundreds of movies and commercials annually, from creature design to prosthetic makeup to animatronics to specialty suits. Our approach incorporates the latest in 3D printing technology with a deep pool of artistic talent. The founding partners at Legacy Effects supervised projects at Stan Winston Studios for 25 years. It was there nearly a decade ago that 3D printing really started to emerge in the special effects workflow.
Back at Stan Winston's studio, the design department was basically working on more visual effects rather than practical effects. So we started playing with different technologies to work hand in hand more with the traditional physical effects that Stan Winston was producing. Fabrication department, the mechanical department, the electronics department, mold making department, and the model shop. We needed to bring design in to contribute. Around 2006,
no, you can. I'm going to just explain. It's very interesting. Huh? It is a movie called Halo 3.
Halo Diorama was extremely ambitious. We ended up creating 700 figurines.
So they created 700 figurines with different emotions. In fact, they have scanned the face of the actor and with different expressions. And based on the different scanning, they produce the parts using 3D print technology with different emotions of the actor. And because during the fighting, you have different emotions, and they are put in this on a table, and they moved around this camera so that they capture it more realistic in nature. So that's what you can see in this video.
7 inches tall.
So they made all these actors 7 inches tall.
Battle. A huge motion control camera went over a stage that was 70 feet long by 30 feet wide. You had vignettes and scenarios, explosions, shots of agony, and people getting killed, hundreds of different poses. That meant that we had to create things really, really quickly.
We utilized the artists that were still in that design room, taking the game assets and converting them into stereolithography files that we could send
to STL file they converted.
To actually produce
See, all mechanical engineering only,
using 3D modeling,
but area of
we would some just to be molded. We would break them apart with arms and legs and heads, put it on a body, and get a variety of different poses out of that one part. There were some that were so specific, we scanned a whole battery of actors in different expressions, then grew their faces, and then we would populate them on different figurines.
It was a perfect testing platform because in the delivery and the amount of characters that needed to be done, traditional sculpting would never have worked just within the deadline.
This tool allowed us to do that job.
When we got into projects like Iron Man, we did a variety of maquettes through 3D printing, additive manufacturing, in acrylics or whichever materials that were being offered up at the time. That was so successful, just growing those maquettes, that I ran some numbers and tried to figure out, well, maybe we could utilize this process in growing the full Iron Man. The numbers worked out, and that was kind of the first one we kicked off as a full-size piece that we did completely rapid prototyping. At that time, we were the first people to do that type of work. It worked out great. We were all really excited about it. Stan was very excited about seeing this process taking the next step.
After the untimely passing of Stan Winston in 2008, we formed Legacy Effects, and we were still in the middle of Avatar, and we had been beta testing new sculpting programs and starting to think, boy, it sure would be great if we had this printer in-house.
We brought in an Objet Eden 260V, which we still use to this day, almost 24/7. In the morning, I could print you a rigid part. After lunch, I could maybe switch and print you a small clear part, and then back by 5 o'clock, I could print you a rubber part, all by pushing a button and changing out materials. That's killer for this studio.
You want fluidity, yeah, and that's what this whole business is based on.
In a feature film now, you'll have 4 months if you're lucky.
We do a tremendous amount of commercial work here, and you have, it could be days, it could be 3 weeks. 6 weeks is luxurious.
That time frame is so shortened that you need to move from the design into actual pieces really quickly.
When you do a design for a character, it ultimately has to be brought into the real world. If you've already had the illustration approved, traditionally you would then have to do either a
See how many
or a
people
study,
are working
and then you'd have that approved
this
before you
industry.
move into the full-size piece.
Mechanical engineers,
Stuff used to
architects,
be modeled in
and
clay.
all these people, the
Iterations would
casting
take several
people, the
days.
design people.
Now we can basically submit something.
So
have it
earlier they used
changed
to
by the
take a lot of
day.
time for making
Concept
all these
design is no
molds,
longer just
etc.
pencil rendering.
But
Concept
now
design is
we
a
are
3D
able to
model.
now make using 3D
Production, the
printing very
directors,
fast.
everyone
All
has
this.
seen it in a turntable, so they know exactly what it looks
Before
like.
they
They've
make
approved it. All we
executive,
have
they
to say
can
is,
make
like, how
small
big you want
props
it.
and
It's all the same
produce
at
on a
that point.
turntable and
We
rotate.
complete a whole
Get the
movie
required
now
shape.
with multiple, say, Iron Man suits or RoboCop suits or 26 robots in real steel in the same amount of time.
Transformer
Spent hand
movie.
sculpting the first Terminator.
Or the Terminator.
If you have the time, sure, sculpt, in clay. If you don't have the time, digital sculpting is really the only method that you have to be able to get something of any
Now you can use 3D printing for entertainment industry, the very big one. So you can use it for such movies, like you might have seen the movies like Iron Man. All these are 3D printed using FDM printer. Now Zero Dark 30, the Navy SEALs. Now these goggles, night vision goggles in that movie, they're using this technology. Initially, the producer want to buy this, but the original one, which is costing $60,000, they have scanned the original one and produced a 3D printed prototype model of it, so that in the movie, when these actors wear it, it appears like a original night vision goggles, right? So like this, the Hobbit trilogy on the special weapons or the mask or the helmets that the actors wear, they are all 3D printed. Or the Guardians of Galaxy, the special guns or the weapons they used in that movie, they are all produced using this technology. Or the Pursuer's suit, this suit is also 3D printed. And Maleficent, another very famous movie, they use 3D printing technology, FDM. In fact, our own Bahubali movie, the entire set, the model of that entire set was now captured by Mumbai-based Softtech. And so that even the original, if you use the original model also, still you can have a replica of that in a smaller version. They put in this Mumbai-based, they captured everything produced using 3D print technology. Let us see how 3D printing can be used in food processing industry. Basically, in food processing industry, use binder jetting, powder bed fusion, or metal jetting, paste extrusion, indirect mold. So these are the applications where you see active participation, eating. You want to have your own eating experience. You want to have your own customized food you want to eat, or cooking experience, or personalized one. You want to do some kind of like a design. You want to create your own kind of the design of the food. You can create model of your own food. You can do it. or you want to have a specific targeted nutritious food, you can combine those ingredients and make only specific food for the applications, right? So this is what food industry is also now using this technology a lot. Customization, co-creation, nutrition, flavor, color, texture. You want your own texture on your food, you can make on demand, on the go production, economy, low volume production, all these things you can use. But basic challenges in 3D printing food industry is the shape stability you should take care. That is additive and recipe control, need for thickeners, enzymes, and etc. Replicate traditional foods also something very challenging. And rheology of food materials vary by time. That means stable print materials needed here. Rheology means the flow of that, all those things will affect. Safety and throughput, all these things are going to be important factors in this. So NASA now using this 3D print technology for its next expedition to Mars. So let us see this video to understand that.
US space agency NASA is funding a company to develop 3D printing of foods. Advocates of 3D printing technology say delivering long-life foods from alternative ingredients could help solve the problem of feeding astronauts and ease food shortages on Earth. Manned space missions require stocks of non-perishable foods. 3D printing could be a promising solution to the problem of feeding crews. Traditionally, food sources perish easily. Proteins, vitamins, fibers, and carbohydrates can be derived from alternative nutrient sources like insects, grasses, algae, and seeds. Stored as powders, they can last for years. When combined with sugars and oils, nutritionally dense foods can be created layer by layer. NASA will provide US firm Anjan Contractor with $125,000 over 6 months to make the technology viable. 3D printing is already used to build complex machine parts and furniture.
Right, so this is how. Now coming to the jewelry industry, 3D printing is using this technology, jewelry industry using this 3D print technology a lot. So especially such innovative designs you can make only with the help of 3D printing. Conventional, very difficult and also very time consuming. So you can see there are different methods in which you can use 3D printing for making jewelry, like investment casting process and direct printing. Investment casting, you can have pattern formation, mold assembly, shell building, burnout. So you first to make this pattern. I know most of you know the investment casting process, where the pattern you can make using 3D print technology, the complicated pattern, any SLA, most popular technologies are SLA, DLP. It's an indirect way of making jewelry. And then once you use it, then you make a mold assembly. Then you have build a tree and dip in a slurry and get the required shell formed outside the surface of this pattern. Then because this pattern is made with wax, you burn out and this wax will melt away. Inside this, you pour the gold, liquid gold, and you get the final part produced. This is how indirectly you can use 3D printing for investment casting process. This video I'm going to show it to you now. Special like jewelry CAD, or you can use traditional CAD knowledge from and once you do it, not with the SLA printer, SLA DLP printer, where you pour the liquid resin with the build plate, and you load the file, and you start printing the part. See how your part is get built. Build the printed, it is from the of the plate, and you can remove the build plate. The anti-gravity leg. See how complex jewelry model is. You can make all these small parts. This is like a general cast, like wax pattern. You're doing and curing here. Then the removing some support structures. This is the final part you pre-post processing. Then they are building the mold tree, keeping all these max pattern produced by 3D printing around the mold tree. Now they are dipping in the slurry. Now they are melting the gold here. So this is a shell form. Then they melt away. Automatically, you see the gold comes out here. So you already poured the gold inside. So now this is how the gold is printed now. Gold, your jewelry is printed. See how beautiful, how complex jewelry you can make using this. Now this is a popular technology adopted by most of jewelry industries around the globe. That's why nowadays you are getting very innovative jewelry, very different designs you are getting. Not only this, see this is one of the parts done by my MTech student for pendant and earrings. Recently we are done using our SLA DL printer available in our center, waxed, and then we produce the jewelry from this. So like this you can get. So before we produce it, we can check in the software of SLA DLP printer, how you orient the parts, everything. Then these are the popular technologies used around the globe, SLA or DLP technologies. These are the metal, castable resin, etc. You can, as well as for direct making the gold jewelry, you can also use direct printing. That is, you can use a powder-based technology like DMLS or direct metal laser sintering or selective laser melting. And using these technologies, you can produce the gold parts. The only thing is the gold thing should be in the form of powder. So that is a very costly process. That's why most of the people will go for investment casting process, which is cheaper. And also what the problem is, the gold, if you get in the form of powder, no, it's, if you lose small 1 gram of gold also, it's so costly. Nowadays you see how much it is costly. I hope most of you might have observed the gold price now. So that's why very less people adopt this one, but still you get better accuracy than investment casting process. So you can see here the 3D printed jewelry by direct metals casting. So you can observe these are the various software used here. Rhinoceros, Jewel Cat they use here. They're the popular machines available in jewelry industry like Model Pro 2 or Envision Tech or Project 3510, etc. Let us watch this video on how 3D printing for direct metal printing process jewelry. This is from EOS. Sector also in all is car bumper, tail lamp, car dashboard, rear wiper motor. They are using 3D print technology a lot. So basically used for communication, validation, pre-production runs, production, customization, all this purpose. You can see under the hood, they use SLS technology. You can make a battery cover. They use interior accessories. You can use SLA technology for making console prototype. Air ducts, you can go for air conditioning ducting, and front bumper, you can use industrial SLA technology. Alternator mounting bracket, that is, you can go for metal bay, SLA and cast. You can do, or you can go for DMLS, like for suspension, wishbone, or you can go for material jetting for dashboard and all those things. So this is now adopted by most popular automobile companies like Ford, Nissan, or you can see the company like Toyota, and all these companies are using this technology. So coming to the electronic industry, as I said, we made this horn antenna using 3D print technology. And these like your remotes, casings, and all these headphones, or whatever you see, all this casing you can make using 3D printing technology. In fact, we made this horn antenna using SketchUp Make software. We modeled this one. Then we printed in our FDM machine. And on this is basically a PLA1. On this, you can coat a metallic coating you can make using copper coating or other material you can coat and use it for some on your account for communication purpose with less loss of signals, etc. Right. So now in electronic industry, they are using they are using either inkjet or aerosol jet. So aerosol jet is the most popular technology that are now being used by this in most of the electronic company, because it will prevent the clogging of nozzles, etc. Like print a phone, and all the parts of the phone can be 3D printed using this technology. In fact, the Nokia concept phone Morph was made using this technology. So you can use it in construction industry also, like I shown. We have printed the model of, and before you construct the actual stadium or a big building, etc., or a village, etc., you can make a model of prototype model of it to understand physically how it looks. Because when even though you see on a computer screen, doesn't bring a lot of information, but if you can make a 3D printed one, it will bring a lot of information, right? So this is what you can see. We have made our arts college, iconic arts college building of smart city model. During centenary celebration, I printed this using 3D print technology, and we made it. So we made in 3 modules and joined them to make the actual building. So we use the FDM Flashforce printer for making these 3 things. So we developed in 3 modules and joined them. So for making the entire building like this, right? So now this is where you can see this is the recent L&T printer printed this 2-floor building, 2-bedroom house within 1 or 6 hours. This is what very interesting application recently observed in the civil industry application. Right. So coming to the interior design application, now a lot of people are using this technology a lot. Especially you can see such a very complicated interior, because you are spending a lot of money on how to make your apartment or your flat or your independent house or everything villa to look beautiful, and shopping place small. So you can make such wonderful things using 3D print technology. In fact, you can see this wall mounted props you can print using 3D print technology a lot. So what is the future of additive manufacturing? This is called Gartner's 3D printed hype cycle curve. So initially we have innovation trigger, a lot of craze about this technology, a lot of expectation. So the expectation increased a lot. So once it reached the peak, a lot of peak of inflated expectation was there. Then immediately you found the limitations of this technology. So there is a trough of disillusionment. So you are able to all you thought this cannot work like this, this cannot. So it came down because of the limitation they found using the 3D print technology. They got all disillusioned and they started coming down. The expectation came down. But later, once the maturity stage came, and they are trying to overcome this limitation of 3D print technology. Now, earlier it is used for prototyping. Now it is called rapid manufacturing. You are directly using the functional parts, everything you are producing using this technology. So now we are in the era of plateau of productivity, slope of enlightenment, and now we are in the era of plateau of productivity, where you are 3D printing technology, you realized its high potential, and now started everywhere it is used. Now that's why it is one of the thrust areas of Government of India, MHRD, or any government around the globe. They are putting this one of the most thrust area where a lot of people's skill sets are required in this area. It is part of Industry 4.0. And that's why it is the next phase of industrial revolution where additive manufacturing is going to play a major role in the developments. Now we have seen the IT revolution. We are going to see in short time 3D printing with IoT technology, with artificial intelligence, machine learning. All of them are now coming together and make our lives more better. So this is what finally I would like to say. I would thank my people who helped. I would also like to thank my students, everyone. In fact, Shari also worked with me in biomedical application a lot. So I thank him also, and thanks to all for patient listening in spite of Ganesh Chaturthi. So any questions? I'm ready to take, Shari.
Any questions from the participants? You can ask directly to the sir. Otherwise, you can chat in the chat box. Any questions? Any questions from the participants side? Please raise your questions. Otherwise, you can write, you can chat in the chat box. You can ask, you can type your questions in the chat box.
Sir, I have a question, sir.
Please identify yourself and ask questions.
Sir, this is Karthik, sir, from MIFI University.
Yeah.
Sir, actually in construction, 3D printing is used in constructions, right, sir?
Mm.
There is a new news that the concrete 3D printing is also, under the research part, because it do you think it will have some limitations? Means constructing a house with 3D printing is not that easy, no, sir?
No, it is now they are having special binders, and you are having. I want to show that video. In fact, I have not shown it to you, so I'll just show to the video. You will understand how this 3D printing can be used. Are you able to see my screen? Yeah.
Yes, sir.
See this video.
No, sir. Yours. I think
sir, screen is not visible, sir.
Screen is not visible. Huh? I stopped sharing. Huh?
No, sir.
Yes, sir.
Yes.
1 minute. Oh, I stopped sharing now.
Yes, sir.
Now is it visible?
Yes, sir. Yes, sir.
This is how you are seeing now. You have extrusion, and through which you have special nozzle. You have a combination of cement and mortar and with special chemicals. So you can like layer by layer they will add and print the entire house. In between they put some special kind of reinforcement. You can see how the reinforcement is done. So now this is already tested. You are putting the walls, everything will be 3D printed, and roof, everything you will fix. Okay, these are the big printers we have. The limitations means the limitation is you can construct the walls, everything very fast, because in the construction process, these are the areas where you take a lot of time. So remaining things is your as usual, like you do your fixing the windows, etc. You do take and modular nowadays. You are getting UPVC windows, etc. And you can fix it very easily using from that in the spot you wherever you want to fix it, the doors, any other thing. I have answered your question.
Sir, what about the strength? Will the strength
is also good.
vary with
They have special, in between they have these pillars. You will have no pillar, this construction. And that walls you are constructing using 3D printing technology. I hope you have seen that video.
Yes, sir.
That is a very small, room, etc. They are making without pillars, etc. But you want to construct a huge, as I shown the 2D, 2-floor building, etc. You have that pillars will be there, but inside that you put this what you call the now you might have heard earlier prefabricated walls, etc. They are fabricated somewhere, brought and fixed. But now you are doing the entire process on the site. They are good strength. The wall is also in good strength. They are already tested. The special chemical they are using and making it strong.
Sir, then why is it not into use completely?
It is not. No, at present,
Into
what is
use,
that?
no, sir.
Still, people are
Presently.
not very much conversant with this technology. Some apprehensions are there. But now in countries like Dubai and etc., they already printed a very big 3D printed building. Just you can go to the net. I hope you can see. You can see a very big 3D printed buildings coming up in Dubai. Already it is there. Somewhat costlier when conventional, but now as the time progresses, now these things will come now. This cost and everything will come.
Sir, here one more question is there, sir, in the short part. So in case of 3D printing, how much are the chance of blowholes and cavities inside the solid model?
This is one problem. You have porosity will be coming up in, because nowadays metal 3D printer, they are 99.99% accurate, but still there is some kind of, it's not like casting process where you get blowholes and cavity, but here you have some kind of what you call gaps or some kind of porosity, because it is not 100% dense like a forging technology, etc. But now with the nano particles impregnation of this, this is also now being overcome in 3D print technology. Yeah, during when you orient the part and build it, if you are not doing planning is not done properly, then there is a question of coming of this porosity or some what you call the in case of FDM, you get this what you call this stacking of this layer one over another and all those things. So you should take care of how you do that orientation, all those things. But still, it is not as strong as the conventional forging and other technologies. But still, no, because the nano printing technology, nano composites is coming up. Nano jetting 3D printers are also available now. You are able to overcome this process, these defects.
Thank you, sir. Thanks for your answer, sir. Second question, sir. Possibility to print stones.
Possibility to print stones.
Is it possible? He's asking.
Stone means this. You want to see the granite stones and all those things. I think
maybe from stone powder to something.
Powder, you can use some powder and again use it, but why I don't know why stone printing for foundation stones, all those things. You require.
I think maybe in the future it will become something.
It may be used, but only thing is you require again the form of some powder, all those things, and make that things. How does porosity come with 100% infill? Is it related to material? Actually, porosity is something it's a part of 3D print technology, because you are adding one layer or another layer. So it is not like you're producing things, for example, forging process, you heat it and then apply suddenly the force, it will fill up the entire. But 3D printing now is 99.9%. Say if you talk about SLA or another technologies, you say it's 99.99%. They will not say 100%. Where still the powder is there, the powder in the form of small granules, and that there is always a chance of gap between the two particles. But now they are filling those gap with the nanoparticles, or if they are completely melting, it is overcoming this process. 100% infill, I think still it's not 100%. No one claims 100% full solid part. But you are hearing 99.99% is related to material. No, not the process. Material is one thing, but process is more important. I think today most of them are interacting.
Yes, sir.
So I hope any questions? Okay.
Any questions? Any questions from the audience? Please ask to the professor.
How does one start with 3D printing career? So you may know, Avantika, you are you are a BE student or ME, or you are a faculty, anything. You should first learn the basics of CAD modeling and good in CAD modeling, and then you should know how to use this BTech second year. Very good. So nice question. So you try to start learning your CAD, everything. By the time you do some internships in third year, in second year, fourth year, do some projects works, then you can, sir, what will, okay, that question I'll ask later. So you can have a lot of companies now coming up with startup companies, 3D printers are there. So you get a chance there to get the jobs there, good career, but with a combination of IoT and artificial intelligence, etc. More requirements are there for you, openings are there. So you can have a good career in 3D printing. What will happen if 3D printed stopped before completion model and after some time it is getting started? How will it affect? So this is another drawback. If there is some power failure, etc., in between you are printing, again, this layer will not adhere to the previous layer. But now it seems some printers are coming up to overcome this technology. But most of the printers, if you stop in between the printing, you have some defect coming up. So generally, there should be very good backup for your printer, electronic support, etc. That is your UPS and other things. There should not be any power failure. So if there's a power failure, there's a chance that you have to again start rebuilding. But people, because you are, for example, you're doing metal extrusion process, you are heating it, and then after some time it stops. Again, new layer comes up. No, then there is a gap between the temperatures, and it will not stick to previous layer. So that's the problem. So is one thing. So you should have a good power backup when you start building part. It will definitely affect the strength.
I have another question, sir. Sir, when the power is cut, suddenly it stops, no, sir. 3D printing will stop. Then, as we know, while 3D printing will divide it into layers, we can directly remove the layer until the layer where we have printed. We can remove it, and if we again start it, will it print properly?
The only thing is when you are printing, no, whether you are going for powder bed fusion or a FDM, etc., you are heating the layer, no. So what happens? For example, the power has failed, and it will start another 10 after 10 minutes. Again, power came. By this time, this layer gets freezed out, and you get a thermal mismatch between them, and these two things will not get joined proper. On the next, even you remove the previous layer also, by the time some kind of gap will come. So that's why nowadays most of the printers have support. Like FDM printers, you can run through a UPS. So like your computer, etc. Even there is a power failure, this UPS will support. Or if it's a big machine like SLM, you have a generators, etc. So there is a definitely, if the machine stops there in between intervals, so when you start next layer, the previous layer will be getting already cooled down. So this will not get adhered to the previous layer. That's the problem.
Okay, sir. Thank you, sir.
Any questions? Any questions from the audience? Any questions from the participant?
Okay. So if there are any questions, they can contact me through email and they can send. You are also welcome. Madam. Madam, welcome. You are also participant, madam.
Yes, sir. Yes, sir.
Please tell me, madam.
Really nice, sir. It's really wonderful.
Madam, I'm unable to hear you, madam, clearly. Hello?
Is it clear, sir?
Yes, madam.
Yes, madam. Please go ahead, madam. Hello? Hello, madam. There is some disturbance, madam, from your side.
Madam, can you chart in the chat box? Actually, some voice is not coming.
Okay, thank you, sir. Thank you for your session.
And now we are able to hear, madam. Please go ahead, madam.
Okay.
Now it's okay.
Now it's okay, madam. Please start.
Clear, sir?
It's clear, madam. Please.
Okay. Really, it's a wonderful session, sir. It's,
Thank you, madam.
I have gone through the session. Of course, last week I missed it because of my other works.
Okay.
But today the session was very nice, sir. It's like a bibliography with all the applications. I think you would have taken so much of time for collecting all these videos from various sources and gathering the information.
Thank you, madam.
One lecture has given us so much information, sir, like what are various applications regarding this 3D printing. Thank you very much, sir, Professor Shivaramakrishna, sir. And
thank you, madam.
Chari, Dr. Chari, and
Thank you, madam.
Thank you, madam.
Thank you,
Happy Vinayak Chavithi, madam, to you.
Thank you, sir.
Thank you, madam.
Thank you.
Thank you, sir.
Thank you, madam. Madam, sir, in chat box, one more question is there. Time permits. Can you give the answer?
Already 11:15. Sir, if we are using, sir, two types of powders for 3D printers, and in between one nozzle stop working, then what will happen with the printing? Two type of nozzles means, for example, it's a dual extrusion FDM process. One is having the parent material, other one is support material. So if your support material is not coming up, then how you can build? That will be a problem. So it will not be able to work, right? So if you are using a dual extrusion nozzle, then the support material should be supplied at correct time. Otherwise, you cannot build a part. Chari, you can also answer this question, I think. You can also.
No, sir. You are the speaker. You had to answer. Okay. Thank you, sir. Thank you, sir. Thank you, sir. Today, Ganesh Hildi also you came and you given a nice presentation about the.
Well, it was only Chari I accepted today, in spite of Chaturthi. But anyway, whenever Chari asks, I cannot say no. He is also such a wonderful student.
Yeah,
so
nice.
Interesting, and I like him very much. He works a lot.
Thank you.
Thank you, Chari, for the opportunity.
Thanks to
Chari and also IFHE.
Yes, sir. Near 34 participants, they are attending the session now, sir. Yeah.
During Vinayak Chavati also. Thank you.
They are very interested in this.
Thank you.
Yeah. Thank you, sir. Thanks. Okay, you were elaborated totally entire the 3D printing applications in today's session. It is a really wonderful session to us. Thank you, sir. Thanks for your support. Thanks for your cooperation.
Thank you, Chari, for your support and for your inviting me to the lecture. Right? Thank you. I am leaving the session, Chari. Happy Vinayak Chavati to Vinayak Chavati to Chari and all the participants. Have a great day. Great Chaturthi. Right? Thank you.
Thank you. The next session will be start from 11:30. The next session starts from the 11:30 a.m. Okay, I have forwarded a Google Form link for your feedback. Please fill the feedback and be available by 11:30 a.m. Thank you. Thanks for your cooperation. Thanks for your support.